Uh, okay. Good afternoon, all my dear students. Please, I'll check. Am I audible? And my screen is visible to you.
Yes, sir.
Okay, thank you. So, dear all students, in the last lecture, we have to study unit number 7, that is programmable communication interface with 8087. That is with the main process of 8086, that numeric data processor, right? So only two topics is there in the seventh unit, that is 8087 NDP and data types and processor architecture, that well-defined architecture and all the working functionality of 8087, and three different types of data types, that is integer, real, and BCD, packed BCD. All these we studied, right? Very small topic, that unit number 7. So today I have to start with last unit. Actually, this is unit number 8. 7 is repeated in the syllabus. It is unit number 8. New syllabus copy I will send to you. You have to see in that. Okay. So in the last unit is remaining for the theory part. All 7 units we are completed. Only last unit is remaining. That last unit today I have to start with. So this is just for 5 hours. Unit is there. 1, 2 or 3 days I have to complete this model, this unit. Okay. So in this unit, just you have to check out the syllabus. There is just three core processor again we have to study. What are those core processor? See, up to now we studied 8086, but in the eighth unit we have to study 80286, 386 and 486. Carefully you have to check in the syllabus. These are extended version of 8086 only. Only the number 2 at the midpoint is added. 2, 3 and 6 or 4. It becomes a 80286 and 80386 and 80486. 2, 3, 4. Second version of 8086, third version of 8086, and fourth version of 8086. So in the eighth unit, entire it is regarding about 8086 only. Just we have to study new version of 8086, second version, third version, and fourth version. That's what they have to add it. 2, 3, and 4. Okay. So in that just we have to study introduction of 80286 microprocessor and its architecture and its real addresses and the mode of operation. Mode of operation, introduction, and architecture of 80286 we have to study. Along with that, protected mode operation also we have to study. And in the 80386 and 80486, just only we have to study architecture. For 80386 and 80486, just we have to study for architecture, and 80286 we studied introduction and architecture, real address mode, and protected mode for operation. This is only the remaining for your theory part of microprocessor. Okay. So dear all students, today I have to start it, and in the next 1 or 2 days I have to completed all the theory part, and remaining only two programs are remaining, that is program number 9 and program number 10. These two programs also I have to complete it either Monday or Tuesday. So if possible tomorrow I have to take these two practical session. Today within evening I have to send a message to you, all of you. So tomorrow, it is Sunday, holiday is there, but I have to take 1 hour class only for these two execution of program number 9 and program number 10. Today please all of you have, sorry, tomorrow please all of you have to attend, and the specified time I will send you within today night. Okay. So this one, as per your syllabus, he said 8 to 10 experiments. So 10 experiments we have to cover. Only up to 1 to 8 experiments already we have done it, and 9 and 8th experiment we will do it tomorrow. So today I have to start with digit number 8, and Monday, Tuesday, within 3 days I have to complete your theory part. Okay. So this is the syllabus of your 8th unit. Now we will start with this 8th unit. So before that, I have to prepare the well-defined notes again for the unit number 8, 80286 architecture. So this is the prepared notes, very fine way I have to prepare. And this one now I have to send to you. Okay, 80386 is there. And 80486, again I want to prepare and I'll send you. So these notes now I have to share with you. Please all of you come to our microprocessor group, microprocessor DSY 21. Okay. So here I have to add the nodes, that is okay. All of you come to this microprocessor DSY 21 WhatsApp group. I have to send you notes number 8. Okay. So please you have to go with this notes, that is microprocessor unit number 8. Okay. So as per your syllabus, we have to start with 80286 of its introduction, architecture, and real address mode operation, protected mode operations. We will study. Okay. So, okay, dear students, one more time I have to check with you. Is it my screen is visible to everyone?
Yes, sir.
Okay, thank you. So, dear students, up to now we have to studied 7 units of microprocessor. Just for 5 minutes, I will revise you all the units. So in the unit number 1, we studied about 8085 microprocessor architecture, pin diagram of 8085, features of 8085 architecture we studied, right? Along with that, some components, system bus, and introduction like microprocessor definitions we studied in the unit number 1. And in the unit number 2, we studied regarding 8086. That is again architecture of 8086, addressing modes we studied in the 8086, and some flag affected flag registers we have to study in the unit number 2. And in the unit number 3, we studied all the necessary instructions. Whatever the instructions are comes near under 70 to 75, 80 instructions. I have to explain you different category of instructions in the unit number 3. And in the unit number 4, again we studied system bus. In that system bus, mainly we have to study maximum mode configuration and minimum mode configuration. So that is up to 4th unit. That is section 1 of syllabus. We have to complete it. And in the section 2, at the unit number 5, that is interrupts we studied. In that interrupts we studied maskable interrupt, non-maskable interrupt, hardware interrupt, software interrupt, and interrupt service routine we studied. Along with that, to solve the interrupt problems, we studied 8259 microprocessor, and 8257 we studied in the unit number 5. Yes. And in the unit number 6, again for the further complicated things we have to solve with 8257 and 8255 we have to study in the unit number 6. And once we studied 8255, 8257, 8259 in the unit number 5 and 6, these are the to solve the problems of abnormalities during the execution of program. And in the unit number 7, we studied one core processor along with 8086 microprocessor. So what is that coprocessor we studied in the seventh unit number 7? That is 8087 coprocessor. So that 8087 coprocessor mainly we have to use it with 8086 for the purpose of numeric processor or numeric data processor purpose. So for this, all the arithmetic and logical processes are going to be increase the speed of execution. That purpose we are using 8087 along with 8086. Is it okay? So up to now, entire this our semester journey, we have to study seven fully units, seven units, right? So in the unit number 8, just we have to study the architecture of extended version of 8086. What is 8086 is the first version. All those things we studied. Second version, that is 80286. This is 80286 and 80386 and 80486 means second version, third version, and fourth version only the remaining in the theory part. So that one also we have to cover in the unit number 8. So now in the unit number 8, all of you got the notes, right? In the WhatsApp group, microprocessor DSY 21, whatever we have a specific group, in that I have to send these notes. Please, all of you have to follow. Otherwise, you have to observe on the screen. Anyone your convenient mode you have to follow. Okay. So now I will start with unit number 8, that is 80286 architecture. So first we have to study the features of this one. What are the features of this one? So as we already studied, we studied as a bus unit, instruction unit, execution unit, and address unit. Okay. So in the bus unit, we studied for it is a unit in the device performs all the memory and input and output reads, writes, and it fetches in instruction bytes and also the control transfer data to and from processor extension. So these devices such as 80287 we have to use it for the fetching the data, retrieve the data, read the data, and write the data to speeding up the process. For that we have to use it 80287 in the bus unit, and along with the instruction unit, the instruction unit is fully decodes up to three pre-fetched instructions, and it holds them in a queue where the execution unit can access them. That is the instruction unit. And execution unit, how well the program is going to be executed, that is 16-bit algebraic and logical unit to execution the instruction. It receives from the instruction unit for the execution, and it is operating in the real address mode. Mainly the 8286 register set is the same as that of what we used in the 8086, because totally the 80286 is an extended version of 8086. All those features it is included, and in the addition of 16-bit machine, the status word or MSW, that is machine status word, one extra things we used in the 8028 for the increase the speed of execution. And in the next address unit, in this it computes the physical address that will be sent out from the memory or input and output with the bus unit, and the 80286 can operating in the real address mode, the address unit, and it computes the addresses using the segment base and the offset addresses. So as we studied earlier, CS means code segment, extra segment ES, data segment DS, and stack segment SS registers are used in the 80286 also. Currently, in the maximum physical address space, the 8086 modes are maximum capacity is 1 megabyte. What is 1 mega in the sense? 10 raised to plus 6, 10 raised to plus 6 megabytes we have to use it in the 80286. That is the maximum capacity to transfer the data in the 8086. That one we are going to use for the to increase the execution of processes. Okay, and in the 8086 is operating in its protected and virtual address mode, and this address unit functions are complicated for the MMU, memory management unit. MMU in the sense what? It's a memory management unit. And in this address mode, the 80286 uses all 24 address lines to access microprocessor to 1 megabytes to access up to the 16 megabytes. Here it is 1 megabytes, but along with the protected virtual address mode, it uses 16 megabytes of physical memory. That's the maximum capacity of data transfer. And in the protected mode, it also provides up to a gigabyte of virtual memory using the descriptor. Okay, so this is about key features of 8086, 80286. And in that we studied pin diagram. So this is the pin diagram of 80286. Just for your reference purpose, I have to made it, but it is not your syllabus. Only features and architecture is there for your syllabus. So just for your extraordinary knowledge, you have to go through this pin configuration. So in the 80286, it has a 16-bit data bus and a 24 non-multiplexed address bus. So that 24-bit address bus allows processor to access the 16 megabytes of physical memory, and whenever it is operating in the protected mode, that time it will use 16 megabytes. So the memory hardware for the 80286 is set up as a odd bank and even bank. Odd bank and even bank means for a particular data transfer of maximum capacity, they have to make it as two categories, that is odd bank and even bank. So in the even bank, it will be enabled whenever the address A0 is low, and the odd bank will be the enabled whenever the bus high enable. BHE means bus high enable is low. So the external buffers are used on the both the address bus and the data bus in the odd and even bank. And the status signals of S0, S1, and memory input and output are decoded by an external to 8 to 8 to 88 bus controller, because you have to use that 8 to 88 in the maximum mode configuration. You may remember now is number 4. Okay, and it provides the control bus read, write, and interrupt acknowledge signals, and hold acknowledgement, interrupt acknowledgement, and non-maskable interrupt. NMI is nothing but non-maskable interrupt, ready state, and clock, and also reset pins have to be same functionality of 80286. Whatever the 80286 is having a functionality, the same functionality of what we used in the 8086 microprocessor. So this is the pin configuration. Just you have to go for this pin configuration of 8086 just for your reference purpose. I have to mention here. And directly I will move to the architecture of 8086. So this one I have to show you. Yes, so this is the architecture of 80286. Okay, 80286 architecture. So here just you have to observe what are the blocks are present over here. So these are the pins. These are the pins that address lines A0 to A23, 24 address lines, and this is the bus high enable, and it is memory input and output. It is a acknowledgement, that is a processor acknowledgement. This is the processor request, and it is a ready state, hold state. S1 and S0 signals are present with the control bus, and interrupt acknowledgement, lock, hold acknowledgement, and the data address lines from D0 to D15. Totally 16 data address lines. So here, this is the address unit. What we studied here now? Okay. So now only how to study at the beginning. address unit is there, execution unit is there, and control unit is there, and next one is instruction unit. Okay, so here this is the portion is instruction unit, and this is the portion is data transceiver in our bus control unit, and this is the portion of execution unit, whatever dotted lines I have to use, and this is the portion of your address unit. So all the address unit, execution unit, control unit, and instruction unit. Okay, so in the previous we studied, right, this one, bus unit, instruction unit, execution unit, and address unit. Come to here in the diagram, that is address unit. We have to say this is the bus unit. See, this is the shaded portion. This is the shaded portion is the bus unit, and this is the shaded portion is the control unit. Yeah, sorry, instruction unit. I have to mention here as a instruction unit, IU, and this is BU, bus unit, and this is the portion of address unit, and this is the portion of execution unit. So in the execution unit, address unit, and instruction unit, bus unit, all four categories blocks of this diagram. So that is in 80286 architecture. First, that is a bus unit. In the bus unit, the bus controller is there. What it will do? It will transfer the data, receive the data by using data bus, control bus, and address bus. Next one is the instruction unit. In this instruction unit, we have to use coded and decoded instructions for the coding and decoding purpose and encoding purpose. So here, this is the portion of addressing unit, that is offset address, segment limit addresses, segment sizes, segment bases, and segment addresses, physical addresses, all we are used in the address unit for to sending the data to a particular address of the memory. And in the last one, that is execution unit. So in this we are using arithmetic and logical unit, registers and control, that non-maskable interrupt, maskable interrupt, errors, and busy signals, all we are using, right, to transfer the data just for next version of 8086, that is second version of 80286 architecture. So what you do, just you have to draw this diagram with a different four blocks, that is bus unit, uh, address unit, execution unit, and instruction unit. Carefully you have to observe on the diagram, and this diagram you have to draw, and first 4 pages you have to explain. So first to 4 points, these are the points is there I have to mention you. So this one you have to execute it. So this is about your 80286. Now come to the mode of operation. So as per your syllabus, this is the architecture what I have to show you. And next come to the real address mode of operation. Next I will go to real mode of operation, address mode of operation, that is real address mode of operation. So in that, these particular pins is used for what, that one we are going to explain. After that we will go for protected mode operation. Next one is protected mode operation. So now as per your syllabus, I have to explain with real address mode operation. Okay, so this is the real address mode operation, that is here up to the 80286, up to the 80286, whatever we studied this architecture, it is reset to start executing an instruction and its real address mode. For that purpose we have to using this is the mode of referred to as real, because the physical memory address are provided by the directly adding on offset to a segment base. In this mode of operation, the 80286 can address up to the 1 megabytes of physical memory address, and the functions essentially as in 8086, because it is almost all the characters are always of 8086. When operating in the real address mode, the interrupt factor table of 8086 is located in the first 1 kilobyte of memory. The 80286 has survival additional built in the interrupt types of follows. So in this, I have to make the functions and interrupt number in the 8086 address mode operation. Here clearly I have to given a table for your easiness purpose. See, whenever the interrupts are happen, oh, sorry. Okay, see, the function and the type of interrupt is occurred. Number of interrupts. Whenever any number is divided by 0 or divided error exception is comes, that is 0 interrupt, and single step interrupt used for 1, and non-maskable interrupt used for 2. 2. Dear students, please all of you carefully listen here. Very important this concept. So for the breakpoint interrupt, use the interrupt number as 3. Are detected overflow and exception, use the 4 number, and bond range exceeded exception used for 5 number, invalid upcode extension used for 6 interrupt number, the processor extension number and available exception used for 7 number. So the interrupt table limited to small used for 8 number, the processor extension segment overrun interrupt used for 9 number, invalid task status segment used for 10 number, segment not present used for 11 number, stack segment overrun or not present used for 12 number, segment overrun exception used for 13 number, and the reserved number 49 to 15, processor extension error interrupt, that is 16, and reserved. So someone interrupts are reserved, that is 17 to 31, and user defined up to 31 means 32 to 255, totally 256 are reserved for user defined. So user can define any number of interrupts after 32 to up to 255 in the 8086, 80286. Okay, so this is the table what we used for address mode of operations. And along with this, the processor separates two interrupts, that is interrupts and exceptions. So interrupts all you studied already in the unit number 5, that is maskable interrupt and non-maskable interrupts. Okay, so now we will study exceptions. Then before that, what is the interrupt? It is the abnormal conditions during the execution of program, asynchronous external events which after the processor throw the interrupt or non-maskable input are referred to as interrupt. That is the definition. So in the second category, because this one everything we studied in the unit number 5, I didn't go much more than that. Just I'll go for the exception. So here in the exception, an exception type of interrupt is generated by the some error condition that occurred during the execution of an instruction. Okay, whatever the error condition is there, that is going to be, we have to overcome the problem. So for that we are using exception. So in an exception type, interrupt is generated by some error condition that occurred during the execution of an instruction. So this one we have to solve it. For that purpose we are using exception. So in the software interrupts, it produced by the interrupt and instructions are classified as exceptions because they are synchronous with the processor. They are synchronous with the processor. So the exceptions are further divided into again two types, that is fault sign traps. Fault is it is an exception that are detected and signaled before the faulting instruction is executed. So there are two kinds of exceptions. One is fault and one is trap. The fault we have to detect it during the exception and we have to get corrected it by the software 80286. Along with that, in the trap also, it is an exception which is reported after the instruction, which caused in the exception executes. And just a minute. Okay, so this is the trap. It is an exception which is reported for uh, after the instruction and which is caused exception executes. Okay. For trap means if whenever any number is divided by zero, automatically you know that it is infinity. Whatever the number you have to divide it by zero, the result is infinity. But our computer don't know what is the infinity. Even there is no infinity keyword is there on the keyboard. There is no any single key of infinity. So in such a conditions, this is going to be solved by using the exceptions. That one is nothing but trap. Okay. So this is for just 2 pages. I have to give a clear explanation about the real address mode operations as per your syllabus. That is real address mode operations. So as an introduction means key features I have to explain, and next one is the architecture I have to explain it, and next real address mode operations I have to explain. Very short, and only this much is more than enough for your exam point of view. So next I will go to protected mode of operation. Next I will go to protected mode of operation. So in that, uh, okay, again come to the notes. This is protected mode of operation. Again, very short. I have to explain you. This much is the protected mode operation. So here, in the 80286, it is already. I said that it is an extended version of 8086, and for the protection of 80286, that is the scenario. In that 80286 based system, it is running in the operating system such as Microsoft operations and which is used the protected mode. So the real mode will be used to initialize peripheral devices and load the main part of the operating system from a disk into the memory. And also it is loads some register and enables the interrupts, set up the descriptor and tables and switch the processor to protected mode. So what is the protected mode? So any of the softwares you have to use. If you are using a Windows operating system, those are not a protected because these are attacked by the virus. So instead of Windows, you have to use Fedora operating system, Ubuntu operating system. Those are the protected ones because they are not get affected by any other viruses. And even you don't need of use to antiviruses. Okay. So here we are using the protected mode in the 8086 for the protection of the other viruses. In that, the first step in the switching and 80286 to protected mode is to set the protection and enable it in the machine status word and it register in the 80286. That is the MSW is nothing but machine status word. So here the memory management in it also we have to study it. But before that, in the machine status world, there is a TS, EM, MP, and PE is there. PE is for protection enable. PE means protection enable. MP means that is monitor processor extension, and EM means that is emulated processor extension, and TS means that is task switch. That is task switch. So here This is the machine status word. So in that, the bit number 1, 2, and 3 of the MSW are for the most used for part of the indicate whether a processor extension is present in the system or not. Just it is going to be checked the processor extension is present in the system or not. And bit 0, this bit 0 of the MSW is used to switch the 80286 into the protected mode to change bits in the MSW, that is machine status word, and it has to be load desired word in the register or memory location. So, and it is executed the load the machine status word, that is LMSW instructions. So this is the 0 bit and bit number 1, 2, 3. 0 is for this P, and 1, 2, and 3 is for MP, EM, and TS. These bits also I have to explain to you. So after the machine status word, we have to look into take care for memory management in it. So in this memory management in it, the final step to get the 80286 operating in the protected mode is to be execute, and in the intersegment jump to the start of the main system, and this program whatever used in memory management, that jump is necessary to flush the instruction byte and the queue because of the protected mode in the functions to be differently enabled in the memory management. And the switching and 80286 to protected mode enables in the integrated memory management unit. MMU means memory management unit to provide the virtual memory and the protection. Okay. So the memory management unit uses 14 bits of the selector and to access a descriptor for the desired segment in a table of descriptor. So the descriptor contains the 24-bit physical addresses, physical base addresses, and it privilege level to sum of control bits for the segment, and it privilege level in the selector is high as of the higher than the privilege level of descriptor. Okay. So then the access to the segment will be allowed. If not, an exception will be generated accordingly, because exception is to solving the problems of overcome. So the memory management unit also checks the pre-state bit in the descriptor to determine if the segment is present, the physical memory. If not, the management memory generates a segment not to present exceptions. Okay, that should be not to present exceptions, because whatever the exceptions are occurred, that is generated for to overcome the problems. So if the memory access meets the privilege level test and the segment is presented in the physical memory, the memory management unit will add the 16-bit and offset from the logical addresses to the 24-bit space addresses from the descriptor. Okay. So, and to produce the 24-bit physical address for the desired byte or the word in the segment, and once an 80286 is switched into protected mode, then there is no any other kind of viruses are going to be attacked, and it is easily executing the LMSW instruction. So what is LMSW instruction? Load machine status word instruction. That is load machine status word instruction. So this is all about 80286. Okay, that is uh, protected mode operations. So, dear students, please come to the syllabus today. Whatever I have to explain to you, this much points just I have to explain. Introductions of 80286 means that features of 80286 microprocessor. That one I have to explain to you today. And architecture, that entire diagram architecture I have to explain to you today. After that, 2 pages I have to clear notes explain to you, that is real address mode of operation and protected mode of operation also I have to explain. So in the today's lecture, I have to explain this much. And in the remaining one more lecture, I have to explain. Remaining topic is only architecture of 80386 and architecture of 80486. So these two architecture I have to explain to you in the next. I think I may got the lecture on Monday or Tuesday. So within Monday or Tuesday, I have to complete your complete theory part of all 8 units. So dear students, now this much portions I have to cover, and remaining 80386 and 80486 we have to link it later. So now what I will do, I will go for the program number 9. Okay, so please all of you open the TOSM software. See, 1 to program number 8 we have to execute it, that is ascending and descending order for the practical session. Please, all of you, take 1 or 2 minute break and switch over to practical session. Okay. In practical session, one more program I have to cover, and because only one portion is remaining, that is 80386 and 80486 in the theory part. That one I have to cover it in the next lecture. Now all of you come to this program. The program is program for to find the largest number in a block of data. All of you open the software, TASM, and come to the, okay, I have to give you the source code of that program. You start to type on the TASM. Okay. After that, parallelly, I also try in my machine. Just a minute. Dear students, am I audible, right, all of you? Hello? Hello, dear students, am I audible? Yes, anyone is there or
Yes,
not?
sir. Yes, sir. You are
Okay,
audible.
okay, thank you. So now I will start with lab session. In the lab session of program number 9. So ninth program we have to practice today. Okay. So this is the program number 9 to find the largest number from a given number, given block of data. Okay. So this is the program. All of you come to the microprocessor group, WhatsApp group. In that, I have to dump program number 9 source code. So all of you go and practice. Along with that, I also show you the demo. Okay. Yes, I sent you a program in the WhatsApp group. Program number 9, that is largest number of a given number. So in the previous, we studied program number 8B and 8A. Okay. So now we will execute the program number 9. Please, all of you start to type in your TOSM software. Along with that, I also type on my machine. Okay. So I have to open my TOSM. It's fine. Okay. So here, for the program number 9, to find the largest means I have to use edit. Name of the file is, I'll take large, LARG, large.asm. Okay. This is my editor. Here I have to start to type the codes. All of you type along with me. second line, that is db we take 08h 14h 05h 0fh 09h. Okay, so next one, we have to find the result, that is res with db. We don't know what is that, so that's what we have to put the question mark. After that, we have to close the data segment. Okay, so next come to the code segment. After that, we will go for assume. What is assumption? CSC is for code and DSC is for data. So next we will start data. Next we will take for move ds comma ax. Next we will go for move cx comma 04h. So this is 04h. After that, we will go for move bl comma 00h. Then we will go for lea source index si comma nums. So here we have to use a loop of, that is move al comma source index. Next compare al comma bl. After that go for jl. Next, so next go for move bl comma al. After that go for next. Okay, so this is the loop. So next we'll go for increment. After that go for decrement of cx register j and z. You go for of loop. After that go for move result res comma bl. So next is int 3, the last line, and you have to use code ends. Code ends. After that, end start. Okay. So this is the program code lines. Okay, fine. So what you will do now? Go and save this program. Go and save. Then you have to exit this. After that, come to the next command, that is tasm. File name is large. File name is large.asm. So here I am getting a one error. We have to check it. Can't locate the fatal command line. Can't locate file large.asm. So it means that warning one. can't locate the file. So here I have to use save as large objects. Okay, this is the program. Save as large. So here I have to save this, and after that, where is the problem? Check. Okay, okay. So there is that's fine. I have to make some mistakes in the program. LARGE. Okay. So here that's fine. So yes, I have to got it in my case, that is LRAG, large. So TASM large dot ASM. Okay, that's fine. So in my program, I have to no errors and no warnings. So next, I will go for third command, that is objective file. So t-link uh, LRAG large dot obj. It's the objective file, right? So here we am getting a warning on no stack. So next I'll go for last command td LRAG dot exe file. Okay, so this is the executable file. So here click on OK, and you have to press 1 or 2 times F7. So here you'll go for CPU, computer CPU, and you have to check it. See, 08, 14, 5, 0F and 9 as per our series. Okay, so as per our series, 08, 14, 05, 0F and 09. We have to got it here, right? So 08, 14, 05, 0F and 09. So now we have to find largest number among of this. What's the largest number among of this? Among of this we have to find. So press F7. See, F7 keep on, you have to pressing. See 14, it will check. Next 5, it will check. See here, in the BX register, all of we are getting 14, right? So 14 is the largest number along with this. So that 14 number is comes here. All of you check it carefully. Please observe it on the screen. So out of 08, 14, 05, 0F, 09, the largest number is 14. So that 14 is showed here. This is output. So one last student, they have to send the output. I think, okay. Yes, that 09709. That's very good. Your answer is right. So one student send me the output. Okay. So I will send you here output. Okay, here one more student also send. Here 14 should be come here. Again 1 or 2 times you have to press F7, you will get it. bx you are getting 14, same number you have to get it. It is right. Okay. So I have to dump it here. This is the output. This is the output. Okay. So this one you have to follow it. So dear friends, today I have to complete a 9th program. What you will do now? You have to practice and send me all of your screenshot to me. All of you send me your output screenshot. Okay, yes, good. 40087. Good. Remaining all the students, please send me output screenshot and try it in your machine. So, dear all students, just 2 minutes, all of you come to my screen. So here, listen, students. Program number 9 is over today, and in the 8th unit, up to only remaining is this much. That is 80386 architecture and 80486 architecture. These two architecture I have to cover in one more lecture. And tomorrow, any one of the time, I will give you for this program lab session. Today evening night, I will send you a message at what time you will have to keep. So tomorrow I will explain this lab program. Okay. So for your syllabus, all of you please be remember only one program is remaining. That is a 10th program, and only these two theory parts are remaining. So only one class for theory and one session for lab. 2 sessions. Within the 2 days, I have to complete your entire 100% syllabus. Okay. So please, all of you keep in your mind and you have to act according to that. So remaining all students, please send me your output screen. Okay, again, I have to got it. Yes, nice. Nice. Very good. Very good. Yes, nice. Very good. Remaining students, please send me output screenshot. Dear all students, again, I have to happy to announce you that only one session is needed for to complete the theory syllabus, and only one session is needed for to complete the lab part. Okay. In only 2 lectures, I have to complete your 100% syllabus. Please, you have to cooperate me. And here, any doubts, please ask me. Are you facing any doubts in the microprocessor? Please let me know. If there is no any questions, then I have to take a pause. And after that, the data structure is taking the lecture. Please, you have to attend. So can I remove? Okay, dear students, fine. Keep on do study. Your examination is very near. Only 10 or 15 days you will have. and your lab second ISC paper we have to conduct in the next week. So there is a very less time. So take a more time to study, and you have to spend more time for the study purpose, and you have to be face the examination. Okay. So thank you, dear all students. I have to take a pause here, and next lecture will start immediately. Thank you all. Now you can log out. Hello.